Algebra 2, Chapter 7.4, Dividing Polynomials. This exercise set 7.4 is one that I set up myself. I didn't like or didn't think it was really appropriate, the level that our textbook have it, so I created my own exercise. I'm going to go over these odd number problems in this set 1 through 13. So we have, first of all, number 1, what is 2x squared plus 3x divided by x? And so the way I would normally write this is this: I'd have this 2x squared plus 3x, and we're going to divide that by x. And so what that's going to do, it's going to give us, we have two terms in the numerator, so we can just rewrite this as 2x squared over x plus 3x over x. And working down below here, we have x squared divided by x. That's going to be x to the second power divided by x to the first power. Well, it's like this, one of these x's cancels the one in the denominator, so we get left here 2x, and then 3x divided by x will be 3. So our numerator here is what's called the dividend, our denominator is called the divisor, and our answer here, 2x plus 3, is our quotient. Next odd number problem we're going to have is 3. If one of the linear factors of x squared plus 8x plus 15 is x plus 5, what is its other linear factor? And so for this, there are so many different ways we can do this that I'm just going to talk about a couple of those. If I take this x squared plus 8x plus 15, we're going to try to rewrite this one in factored form. Now, because of what we've been told that one of the linear factors of this quadratic trinomial is x plus 5. So we can write this x plus 5 here, and then we can ask ourselves some questions like, what times x equals x squared? Well, that's going to be x. And then we have to equal this 15. So what times 5 equals 15? Well, that's going to be plus 3. And so what this tells us, that our other linear factor is going to be x plus 3. And then you can use a box method also. If you take a box like this, do like a square like this, and set it up so you have a 2 by 2. And if you put, you take this x squared and put this in the upper left box, and the 15 in the lower right box, and you know that one of the factors already is x plus 5. You can write that right on top. And then on the left here, we know that x times what equals x squared? Well, that's going to be x. And then x times 5 is going to be 5x. And then down below here, what do we have to multiply by 5 to get 15? Well, that's 3. So here we can see that we have diagonally oriented here. This 3x plus 5x is our 8x. So that's going to be number 3 worked out. And there's still more ways to do this than I mentioned. One of which is a polynomial division or synthetic division. Okay, here we have, what is 2x squared minus 5x plus 3 over x minus 1. And I'm going to do this a couple of different ways. I'm going to do a polynomial long division. So I'm going to make a long division bracket and put inside that bracket 2x squared minus 5x plus 3, and we're going to put our divisor on the outside, which is x minus 1. And then if we take 2x squared divided by x, we're going to get 2x, and then 2x times x is 2x squared, and then 2x times negative 1 is going to be negative 2x. And then what we're going to do is a part that makes this, for some people, polynomial long division difficult. We have to take negative 5 minus negative 2x. Well, that's going to be negative 3x. It's going to be like negative 5 plus 2, and we're going to bring down this 3, okay, plus 3 like this. So we're going to have negative 3x divided by x is minus 3, and 3 times negative 3 times x is negative 3x, and then negative 3 times negative 1 is 3. And then we add these together and get a remainder of 0. So our answer to this question, which is our quotient, is going to be 2x plus 3, which is our answer. And we can do this with synthetic division. If we create a synthetic division bracket like this, we take the value of the 0 on the outside. So a point of confusion is people sometimes will put that number negative 1, where you're going to have to put positive 1 out here. And then we put in 2 representing the 2x squared, and negative 5 representing negative 5x, and finally 3 representing the number. We bring down this 2, and so what this 2 is, it's going to be our x place, because it's going to be 2x squared divided by x. Then we take 1 times 2 is 2, negative 5 plus 2 is 3, and so this will be 3, as in 3 the number, and then we have 1 times 3 is 3, and something is amiss here. Okay, yeah, because that's supposed to be negative 3 down here, and 1 times negative 3 is negative 3 and 0. So we get this 2 and negative 3, which also represents 2x minus 3. Okay, next on our problem we're going to go over is number 7. A rectangle has an area that can be represented by x squared plus x minus 20. What is the length of the rectangle if its width is represented by x minus 4? And so what we have is our area is going to be equal to our length times width. And so if we have our area, which is going to be x squared plus x minus 20, that's going to be equal to, they're asking what is the length, so it's going to be length if the width is represented by x minus 4. And so to solve for L, if we divide both sides by x minus 4, we will have solved for L. So L is going to be this worked out. So I'm going to make this a synthetic division problem again by putting our value of 4 on the outside here, and then 1x squared plus 1x minus 20, and we bring down this 1, so we get 1. 4 times 1 is 4. Then we get 5. 4 times 5 is 20. We get a remainder of 0. So what we have is x plus 5. So we're going to have our length is equal to x plus 5. And you can multiply these back together again to see. You can solve this by factoring. If you put this, make this box like this, you can make this, you can put x squared in the upper left and put negative 20 in the lower right, and then put your x minus 4 on top, and then you're going to have to see that the only way this thing works out is for you to put x and plus 5 on the side. And so that's what that one looks like. Next odd number problem we'll look at is 9. A rectangle's area and length are shown below. What expression can be used to represent the width of the rectangle? So it's going to be similar to problem 7. So we can take, I'm going to just use synthetic division again. We're going to take the area here, which is 1x squared plus 7x minus 30, and we put the value of the 0. So if we say x plus 10 is equal to 0, x is equal to negative 10. So therefore negative 10 is going to go on the outside here. So we bring down this 1. So we're going to get 1x, and negative 10 times 1 is going to be negative 10. And 7 plus negative 10 is negative 3. Negative 10 times negative 3 is 30. So we get a remainder of 0. And so our width is going to be equal to x minus 3. So you could write, so our length is x plus 10. Our width over here equals x minus 3. And we can multiply these together and get our area. So that's number 9 worked out. Now number 11, a similar type of problem. We got this one right here. Similar type of problem. We're going to take our length. We're going to find the length. It's going to be our width, our area divided by our width. So we go here, we can set this up. We have 4 representing 4x squared, minus 11 representing minus 11x, and finally minus 3. And we bring out the value of the 0 here, which is 3. So we bring down this 4. So we're going to have 4. Our length is going to be 4x, and 3 times 4 is 12. Negative 11 plus 12 is 1. So 4x plus 1, and 3 times 1 is 3, and we get a remainder of 0. So for this one, our length is going to be equal to 4x plus 1. And the last one I'm going to go over in this exercise set is number 13. And what we have is, we have rectangles, an area that can be represented by 3x squared minus 34x plus 40. What is the width of the rectangle if its length is represented by 3x minus 4? And for this one, we could possibly do synthetic division, but I have found if you don't have a single x, probably an easier way to go is to use polynomial long division. And so I'm going to set this up. I'm going to make a long division bracket here and put our 3x squared minus 34x plus 40, and we are going to divide by our divisor, which is 3x minus 4. So the first thing we're going to do is take our 3x squared divided by 3x. Well, that's going to end up being x, because x times, and then x times 3x is going to be 3x squared, and then we take this x times negative 4, so we get negative 4x. And now we're going to subtract. Again, this requires integer arithmetic, which is a downfall of many of us, myself included at times. So what we're going to have here is 3x squared minus 3x squared, of course, is going to be 0. And then we have negative 34x minus negative 4x. Well, that's going to end up being negative 30x. And then we bring down this 40. And then we have negative 30x divided by 3x. Well, that's going to be minus 10. And then negative 10 times negative 3x is going to be negative 30x. And then we have negative 10 times negative 4 is going to be plus 40. And then we subtract this out here and get a remainder of 0. And that being the case, we know our width is going to be equal to the quantity x minus 10. So that's our answer, and that's all the odd number problems. Good luck. I hope this has been helpful. Thank you for viewing.